Yeah, very happy to introduce STÖK and joohoi, who are going to be talking to us all about flipping bits and stealing credentials and, well, all sorts. So, yeah, over to you. Thank you.
Wow, cool stuff. I'm really happy that a bunch of you are here. We're closing down Andromeda tonight. I think that's pretty badass.
Yep.
So the thing is that we got about 265 slides to go through in the next 45 minutes, so you better buckle up, Dorothy, because this is going to be fun. Hi, I'm STÖK, this is joohoi, and we are here because we are on tour for the release of our new album, Pure Scandinavian Darkness. Pretty sweet. No, I'm just kidding. We're here to actually talk about bitflips, space weather, heat, voltage, and other weird stuff that makes all our devices, computer and shit, go haywire and do idiotic things like fetch resources they're absolutely not supposed to do, or send leaked credentials to places they weren't supposed to end up. And while we're speaking on sending things, how about emails? Maybe they shouldn't be sending those to the weird places as well. Because if we look into this beautiful email Slack invite that we got for this domain, it says vismq. And that's like particularly close to the company name that you and I work for, right?
Oh yeah, sure is. However, in this case, it's not really a bitflip, which is what this talk is about, but it's a typo instead. And when you look to your keyboard, it's, you know, like a Q is right next to the A, and this is just a misplacement of a hand on a keyboard and so on. So not a bitflip per se. Exactly,
but we're not here to talk about malfunctioning keyboard. We're here to talk about bitflips. And what's particularly cool with just bitflips is all it takes is a single 1 to turn into a 0, or 0 to turn into 1 to change everything. Because if you take this domain here, google.com, for instance, the G in google.com is built around these ones and zeros. If we flip one of these bits, let's say this one from a 1 to 0, it turns into google.com. If we flip these two, it's google.com, and hey, why not this one? It's google.com. Speaking of W, if we flip this one from a 0 on wordpress.com, we got gordpress.com. And that's, which is pretty nice. And that's a domain you could actually buy.
Or not. So after we did our first talk, it's not owned by us, but somebody grabbed it. So yeah, have fun with it, I guess.
After Black Hat, somebody bought it. So hey, let's go. And this is the term called bit squatting. And somebody that was really early on this was Artem Dinnerberg. His research is the base of all this. Because at Black Hat 11, he presented a really cool talk on flips in DNS. And just to explain this whole thing, what bit squatting is, I'm going to be lazy and read this part out for you because I didn't memorize it. Bit squatting is a form of cyber squatting which relies on bit flip errors that occurs during the process of making a DNS request. These bit flips may occur due to factors such as faulty hardware or cosmic rays. I'm like, this could be interesting. And this was actually the nerd snipe that I got from my friend Dylan A. He's the guy that created Trufflehog. And he said that he bought a bunch of domains from googleapis.com, which is surprisingly kind of close to googleapis.com. And he said that due to cosmic rays, he collected shitloads of loot. And that loot was API tokens, it was JavaScript file requests, and a whole lot of more stuff. And at this stage, I'm like, ooh. I'm going to have me some of that shit. So I'm like, how do you do it? He's like, oh, well, hey, man, it's very easy. All you need to do is to buy a bunch, flip domains, and catch all the DNS requests, write some simple code, and then store it all in a log file.
Easy, right?
Well, since all you are super smart people, I'm just going to break down how this would work over DNS and HTTP. So we understand what the process that he described, or at least both Artem's work, the initial one that we're building this upon. So let's say that we have a normal GET request to get an authentication. Dance started. The client's going to connect to the upstream root DNS. That's going to point you to the SOA that says, hey, bro, this is the IP address of the domain you're looking for. Client's going to be happy, connect directly to the web server, do the first part of the dance. Then we'd ask, where should I go politely? The server is going to respond back and say, hey, bro, you're actually going to head over to this place and do the post request with your secret token, all that stuff. But what if some magic stuff suddenly happens and the domain flips in the device's memory? So now instead of WordPress.com, we have GorePress.com. Well, what's going to happen is you're going to have the same DNS lookup dance, but in this case, it's going to connect to the owner of the name server of WordPress, which is going to reply back with another IP address, but for another domain. The client's going to still be super happy because it flipped in memory, so it's just going to send whatever token over to that. But the thing is that this only works over HTTP. We're not living in that world anymore. So,
and nowadays, like most of our communication over HTTP is HTTPS. And nowadays, the same thing that worked 10 years ago would result into this instead.
And this sucks. And
well, I like it actually.
And the reason why this is happening, we need to at least look at certificates for a short while. And a very easy way, if you want to have multiple domains stored in a single certificate, which we want to do if we're doing bitflips, right? We need to use, for instance, the Saas certificate, where we would define the ones, we're pre-staging what we're looking for. Or we could get a wildcard certificate, which is great, because now it's going to serve an OK certificate for any kind of subdomain that's in the first level of the domain. So www, log, and whatever. And that's all good. But let's say that we change this domain instead from the www to this out.webapi-something.com. Well,
yep, not working again, because wildcard certificates, they are only good for one level. So yes, they are not wildcards in the same sense than in many popular file systems, for example, but just one level.
How many of you have stumbled upon websites that have more than one of these nowadays? Server hosting, they're yay long. So it's a lot of work to get this to function, because for each level you go into, you're going to have another wildcard certificate for that kind of level. So it could be like EMA, whatever things that you want to get that working. So what in theory would be easy is in reality quite hard. Because I realized to get this to function, I don't want to do this job all the time, because what I wanted to do is, I always want to buy a couple of domains, then I want to set up it. Then I had to set up this by9 to generate all these certificates, because I needed to specify exactly the response coming back for the domain that I wanted. And I also had to have this nginx proxy to forward it to Let's Encrypt. And then manually, also to show ownership of this, I needed to have this token for this path that Let's Encrypt is going to do. And that was all good and all. But the reality, I needed to do that every 90 days for every kind of domain that I had. So I'm like, maybe I should automate this. But at this stage, I'm so tired of this project. I'm like, next. And I totally forgot about that I had this up and running for 2 years. Until I got this nice email from my VPS provider. It said hey, dear valued customer, your VPS Flippy McFlippyface is running out of disk space. And I'm like, what? Oh shit, I remember that project. I had that VPS up and running. So lo and behold, logged into the system and realized that it was out of space. And it wasn't where I thought it was. No, it was in my catch file that contained all the nice loot that I've been collecting for about 2 years.
So, meanwhile in Finland, I love self-hosting, probably many of you in the crowd as well. So I've been self-hosting my stuff for the better part of 20-something years. And for the purpose of this section of the talk, we're going to use domains that allow us to use cool cassette graphics and all that retro stuff. So we're talking about this fictional domain that I actually never owned. And the reason, by the way, why we're using these fictional domains is that we didn't get a permission to release the target of the real story. So I purchased this short domain, l0.fi, fictional one. And I do what I always do when setting up my email and stuff like that. I do a catch-all email. Basically meaning that everything that lands into my, well, anything at mydomain.cld will land into my inbox. And this allows me to register using different usernames for each service, because email addresses are usernames nowadays. So when eventually somebody steals my data, I'm just able to block them off and get rid of all of that stuff. And I know who it was. So I set up my infrastructure like I do, and I started receiving email for a bank. And I'm a bit confused here, like why? But yeah, it's actually obvious because I own the domain l0.fi, and there's a fictional bank in Finland with the domain lo.fi. O and 0 basically right next to each other on the keyboard, also visually looking the same. So now, suddenly, I'm every person that works in that bank, all the support contacts, everything for people who make typos. So I do whatever a responsible person does. I contact their security people using email. So, hi, it's me. I have this weird thing going on. I would like to get it fixed. So could you please help me? And no. There's no response. The problem itself in nature is it's not a technical one that can be solved easily. So I kind of understand the confusion. So I don't give up. I call them. Could you please help me? This is kind of annoying. I don't really want to be in charge of people's bank details, the stuff like that. And they're not able to find anyone. Nobody to help me. So, okay, I guess the problem goes unresolved for now. And weeks go by. I still get email, and I start to get new type of email. So, do you know this bad boy? What it can do? It can print stuff, right? Well, actually scan stuff as well. So that's cool and all. And in a context of a bank, for example, the stuff it scans is like a contracts, digitizing all the paper stuff from a bank. And if you plug that to a network, it can also send stuff.
I wonder where this is going.
Yeah, me as well. So if you get this bad boy to send stuff, make sure that it's configured correctly, because this wasn't in one of the bank's branch offices. So now I'm also getting this contractual stuff into my email as attachments. Not nice. So still, problem goes unresolved. Weeks go by and summer comes along, and what do you do during the summer?
I go on vacation.
You go to a hacker camp, right?
Yes!
So now you know also the timeline of the story, I guess. So yeah, there's a great camp, Sha, where we had our Finnish village. And by the way, we brought the sauna here the first time around in Sha as well. And in our village, there were also some people from NCSFI, the cyber people of the government, Traficom. Awesome people. Huge kudos, huge kudos. They are basically part of the community, the hacker community in Finland, and they are really, really making sure that things get done the best way that they can, respecting the privacy, helping the hackers out, helping the whole country out. Except you. Okay, so they understand the severity, okay, we can connect to you. We have a hotline to the bank, so we can get you set up communication running. But obviously, I didn't have my keys to access the infrastructure from here and so on. So okay, it has been going on for a couple of months already, so maybe it's not the case of a day or two. So let's figure out the whole thing when we get back home. And they delivered like they always deliver. They contacted me to people at the bank. Well, actually a person at the bank. A lawyer. No. It was not a malicious thing in any way or form. The discussion was actually pretty civil. There's no real technical solution to the problem. And the real solution was for me to just give up the domain to the bank. I didn't have anything like a super important there, so all good. At least I get rid of the bank emails. And this is where my story should end, right? Guess what? No. A couple of years in the future, I registered a new domain, ki.fi. Set it up like I do. Hey, my old friends from the bank are back. Guess what happened here? I can tell you, it's a one-off error. So yeah, and then at this point I obviously have a good connection to the people at the bank, and I'm like, hey, it's me again. You never guess what? But yeah, and this time around I was not going to give up the domain. Like it has nothing to do with the real one and so on. But they actually, kind of not because of my thing here, but they ended up fixing it the best way possible, getting rid of the emails for customer communication altogether. Everything happens in the actual banking application now. And this is where this part of the story actually ends.
But it's also where another one begins, because so I went to Disobey in January last year. And Jonah and I, we are friends, so I shared all the loot that I found, and I asked him a bit like, hey, I mean, my setup is janky. There's a lot of things that I could need some help with you, since you know certificates better than I do, then maybe we can do some cool things with this. Because we needed to more or less rewrite everything.
Well, you could automate part of that, and at the same time, the rewriting everything would be a kind of a huge task, and we're not like young guys anymore, but we are rather drunk after the 4 NEPAs and all that good stuff. So yeah, hell yeah, let's do it. And we ended up rewriting the whole thing from scratch.
We scratched all of it. That was shitloads of work. But what we instead did end up with was a custom DNS server and a custom HTTP server, custom mail server, a nice certificate management system, a payload injection capability using template engine.
Because why not?
We should have a support for multiple protocol, extended config files so you can tweak it any way that you like, and a nice JSON format log setup, and an easy getting started 5-minute setup. And we figured this is a cool thing. What should we call this a very helpful thing? Well, let's call it Certainly. Because what Certainly does, it's your friendly butler that listens and says yes to everything. Because no matter what you're going to say, it's going to say, yes, exactly, that's the right thing. And it's pretty cool because it has the support of delivering on-the-fly certificate generation. So whatever you come with, we're going to serve you. And it also has the possibility to inject custom payloads in case you wanted to sneak some other things in there to the response for the client. And also a first-class safe logging credential service. So we make sure that your credentials are safe in our log files. So how would Certainly work in the scenario that we had before? Remember this funny part where we're like, okay, it flips in memory, WordPress now turns into WordPress, and it's going to be sent over to the top DNS. In this case, the Certainly server is going to respond back, and it's super happy because it's a wildcard by design catch-all DNS server. So it's going to respond back with whatever address connected to that matching pair of DNS, because you set it up in this case where you have WordPress and its matching pair WordPress. So it will know, okay, that's a cool thing, we're going to respond back for you. In the first trial runs, we followed the recommendation in Artem's work to enable DNS poisoning, which meant that we also sent the original request along the line. This ends up in caching things and breaks internet stuff. So we removed that. So there's no, and set the TTL to 1 second instead, because we figured that that was enough for us to do a proof of concept. But it is open source. So the response is going to go back to the client. Client's going to be like, oh yeah, nice, a cool place to go. Well, I prefer HTTPS, so should we have a TLS handshake?
Yeah, sure. And this is basically where the TLS handshake takes over. Obviously, starting with the client hello, the client telling the server which domain it needs a valid certificate for. And in this situation, certainly we'll tell the client to hold up, while in the background, it runs to the CA and goes like, hey, if that's like a pretty urgent question, could I get this certificate signed real fast because I have a really important customer waiting and I would really like to serve this request for them. And the CA will ask certainly to provide the proof of the ownership of the domain. And as you may remember, certainly is the DNS authoritative DNS server for this domain. So it's super fast and swift. So it will be able to answer correctly to the challenge. This means that the CA is super happy to sign the certificate and send it over back to certainly, which then again will serve this certificate to the waiting client that has been on average at this point waiting for the whole 4 seconds. So this releases the whole TCP session again within, like, after basically 4 seconds, which means that the initial request doesn't even time out. So we were able to catch the very, very first one for each domain as well.
Because that's mattered, and we're going to talk more about that later. But what's happening now is that we got a fresh, juicy, nice certificate to serve the client, and the client is like, oh yeah, super good, nice. Here's whatever post request with whatever tokens that I have. And we think that's cool, and we can probably kill the connection there, but we realized after some tinkering, if we're playing ball here and says like, okay, we're just going to take your credits, put them in the log files, but we will respond with a 307 temporary redirect to the original matching domain, that means that we will just silently like, here you go, we didn't hear anything, and we're slowly walking out the door. Communication continues. And this is great, because if you work in any kind of service, you realize that if you're treating your clients right, they might be returning customers.
So yeah.
And when that happens...
yeah. I mean, we can also spice things up a bit. You remember the injection support, I guess. So in this part, obviously, the client asks for a resource from certainly that the client actually thinks is another one, upstream domain, actually. So certainly, again, asks the client kindly to wait for a bit while it runs in the background and requests the content from the original source, using all the request headers, stuff like that, basically acting as a man in the middle. And when the original target responds, it will pick up all the stuff, including the response headers and basically having those. So this obviously allows us to add a bit of spice there if we want to kind of return spicy responses. And yeah, sending it all back to the client that is super happy to receive data in a format that they were expecting. And yeah, we can do pretty much, we're in the control of the whole traffic there, so we can do whatever.
It's beautiful. Inline injection support on the fly. Beautiful. So I said that's pretty sweet. And now you're sitting there thinking like, I want me some of that using stuff. It's like, yeah, sure. But how do you get the domains? Well, there's a great talk that you can watch that Luke Young did back at DEF CON 23, it's a while ago. It's really cool. He shares all his data and research and all. And he also shows how to get domains real cheap. But he also released a cool tool called BF-lookup. And what that does is that simple Go file that you run, and you're going to see the domains that are available for you to register. And in this case, on WordPress, there were 28 bitflipped domains that would be possible to register. And
one bit away.
Yes, and that would be steep cost, not the first year, but the third year when they want you to renew them. And you have a bunch of these, I mean, it get exceptionally expensive. So we needed to find a way to funnel down. I mean, like, okay, is there a higher probability that some characters will flip or not? So I found this really nice research paper by super smart people, them. It contains a lot of data and numbers and math and stuff. And it says that, it's a higher probability that it will go from 1 to 0 due to the fact that it has something to do with keeping a charge to require more power than letting it go.
Electricity and magic, you know.
Smart people. So what do? We look for the characters that have the most ones. And that's O and it's W. And we realize that O and W, they have something called character siblings, which means that O happily could turn into K, G, M, N, and L. W, S, V, G, C, P. But those aren't the only ones. There's a nice number of these. So O and W have 5 siblings, CEF has 4, and then it just continues down to whatever thing that you're looking for.
You there in the back, are you able to see the last line?
If not, we got news for you.
Yeah.
Anyway, we do it on the side of the spectrum. Which one has the most zeros? Because they're also probable to flip, right? And it's A and B. So if we take WordPress here again, and let's say that we switch all these ones here to zeros, what's going to happen? Well, it's going to change the character of the casing of the character.
And DNS doesn't care about that stuff, so.
We don't give a fuck. So if you've seen this in your log files, probably there's some kind of flip. Not someone is sitting there like, delete WordPress. So, and on the other end, when this happens, if you flip these ones here to zeros instead, what's going to happen then? A and B turns into a backtick. And backticks are cool.
Yeah, but not really in this context. DNS doesn't like it. We cannot really. We allow backticks in offensive security, usually. But here it's useless.
But this is just to spice your mind where this could happen. In theory, maybe you smuggle in a good backtick. So, because remember this, all it takes is 1 0. This one to turn into 0 to turn WordPress into WordPress. That's simple. And if we look at all these ones with O's and W's, and all these KGM and LNM, to funnel down which are most likely to flip. Well, according to the numbers that we collected, it's actually K. So K is O has the highest probability to turn into K, then it's G, and then it's M. So easy for us. The ROI would be to buy K. If you're only going to buy one, buy the one that turns into K. But somebody else already had bought that. Sucks for us. But we have 5 other ones that are high probability ones to buy. So we can get those.
So this is actually pretty nice, but maybe we could have more impact if we, or is it actually possible to do this for top-level domains?
Do you mean, how about top-level domains? Yeah, we did a quick check at IANA, and it shows that there's somewhere around 1,446 TLDs available. And I did that I did the same thing that any respectful hardcore engineer would do. I vibe coded a Python script that put all the stuff in and asked ChatGPT to, are there any siblings? And it seems to be that there's actually 348 domain that likes to turn into something else that's valid. Pretty sweet. That's a lot of number. So an example would be .io, for instance. It likes to flip into .im, which is the Isle of Man. So here you can easily buy a .im domain for 20 euros. Somebody did that for metamask.im.
Not us.
For some good reason. I know that Adobe has Adobe.io, though, for all their dev stuff. I wonder. The most interesting one would be .com, though. I mean, that would be dreamy. And we realized that C flips into B, so .bomb. And .bomb is a new and upcoming domain. Oops. Oops, here we go. There. Oops, where am I even? Here we go. .com. Here, .bomb. Because bomb apparently means good in Portuguese. And that's great and all. So now I'm the proud pre-registration owner of Amazon.bomb.
It most likely won't fall into your hands, though. They're vetting that stuff for sure.
Well, slim chance that happens. But anyway, if you really want to spice it up, the dreamiest of the dreamiest would be to get CKM. I mean, you would get everything. And that's actually doable if you're into getting a vanity TLD. That's doable, but it comes at quite the price.
Yeah, I mean, like it's get poor fast scheme, basically, because there's a pretty hefty evaluation fee of $185,000. That is not the purchase, but it's a cost for getting your request evaluated.
Yes, and they do this like every 7 years or so. And they have a very short application window. So now is your time to get that dreamy startup that we ever wanted and call it KCM something. And then you can sell the domain to me. But we set up to play around with this whole idea that the intention why we did certainly was we like space stuff. So we figured that, okay, cool, we got certainly up and running. Everything is awesome. Let's replicate the results of my janky setup with a streamlined, cool new setup for science, not for loot. So we began with some nice bit squatting, which means that we bought 25 domains from different Saas and cloud providers, package repos and different providers that are dependent on getting stuff. And we let it run for about 4 months and 23 days. And we waited for something to happen. And oh boy, did we get lucky. Because on May 24th, the 10th, the Earth got hit by the greatest solar storm in over 20 years. And we got our whole infrastructure up and running, so we're like, holy shit! And it went on for multiple days. And we agreed to not look at the log files because we were like, oh, it's going to be so good.
But we agreed not to analyze the log files before the whole thing was done so we could, see the bigger picture.
Science.
And we waited, not patiently, but we waited. And then we actually analyzed the logs and we saw nothing. Actually lower than average, to be honest. Well, we still got results from a larger time span of the research, so we submitted the stuff in and got accepted to talk at conferences like this one.
But we just could improve it. I mean, we were excited to space better.
But awesome. It's anyway, we were on our way to Vegas to present this, and on our way there, at the airport, still trying to figure out what the hell is going on, we stumbled upon a new research paper that looks into a correlation between DRAM errors and cosmic rays. It's a pretty large, hefty research with a huge data set that is done by Barcelona Supercomputing Center, European Space Agency, and the University of Athens.
Smart people.
Smart people. And in their conclusion, they find no correlation between the cosmic rays and DRAM errors. And in fact, they go in and recommend people who made previous research on the topic to revisit their research on the light of this new data.
Because even though this was the thing that we set up to think, because our industry has agreed that it is spaceware, that's the thing. But fact remains, even though it wasn't space weather. We collected about 62 million DNS requests coming in. And those turned into about 2.8 signed HTTPS connections. We got about 15,000 emails.
Yeah, that's a lot of Viagra.
And Nigerian princes. But we also, this bad boy came back.
Our old friend.
Because it shows that some weird way you're using these e-tags that can flip in a way that, you know, suddenly we got a nice scans from random places. And we got about 2,300 OAuth and OAuth refresh tokens. That's a lot of loot for a couple of Fortune 500 companies. And if you're thinking about just doing this for the fun of it, it's also a great way for you to collect like really good targeted word lists for DNS lookups.
Yeah, you know, like these split horizon DNS setups and stuff like that. When the target domain flips, it usually goes out and we catch it.
And for some reason, DNS seems to flip very often. So we got very accurate setups of infrastructure, knowing how things were running. But in the beginning, we did SARN certificate, one certificate for each of them before we moved into the wildcards. And that meant that for each and every certificate request we get, the scanner boys came running. So our systems got pretty flooded. But the perk side is that we got the best and the latest scanners from anyone that was broadcasting the internet.
Yeah.
So we could more or less build our own, bug bounty automation now, because their shit is just collecting whatever they do.
And the reason why the scanner boys came running is that obviously each registered certificate ends up in the certificate transparency logs. And they basically monitor that, and like any new domain that they haven't seen before, they're going to blast their payloads in.
But we're not only the bad guys, so obviously you're wondering, but if I'm supposed to do anything, what am I supposed to do?
Yeah, this is the boring part. Take responsibility, obviously. Like whatever is in your control, try to fix stuff. As an example, the easiest thing is obviously, register these domains, especially the more likely characters to flip. And yeah, basically don't be like WordPress here, but be like Amazon instead. They basically have all of it. Everything. And since we actually saw a huge overrepresentation of mobile application, or rather mobile devices in our data, there's something that is available in mobile that is not available basically in other parts of the communication, and that is certificate pinning. It's a really, really effective thing against these bit flips, but in case you go that route, make sure to implement that correctly. Because we were talking to a large company that had basically all of their traffic over mobile devices, and their implementation had basically a list of domains and the corresponding certificates, fingerprints, but if the domain was not found on that list, it would fail open. And our domains, obviously bitflip domains, non-expected, would always fail open. So if you go that route, make sure to implement that correctly. And the last one, and probably the most effective one, is to go to programming language core network libraries and do a OpenBSD pledge sort of jingaroo, where during the application initialization, you list up the domains that you're expecting to be communicating with, and if this whatever certificate upon validating it does not match to that, just kill the connection and you're good.
Or you can do like most of the companies that we talk to. You can blame it on DNS. And live blissfully ever after, keeping ignoring it. I don't mind. I'll keep on saving those nice creds for you in a secure place until you decide that it becomes a problem. So why is this even happening? Well, the open and real transparent answer, we have no idea. That's why this is a call for research paper. Because the thing is that the agreement that we had that bitflips rarely happens, I think the reason is that it just rarely got caught. Because it happens a lot in all these apps and devices. We've seen everything from TV devices to in-house, anything that's more or less connected to the internet.
Your toaster is going to flip.
Yeah, no, it's the crappier of the hardware, the more likely it's going to flip. But it's also the latest build of the latest iPhones. So it's over the whole spectra. And if that has to do with some kind of row hammer situation, that the memory is getting read, the first character, for instance, in the application all the time, and then suddenly it flips in memory, and that means that it's going to be a clean request going out, or if it's the CPU or the CPU cache, maybe the memory channels or the networking libraries or networking equipment.
Snipe! So we were definitely nerd sniped by this whole idea, and I really hope that we got your brain racing as well, even though it's like pretty late, but yeah.
I hope you're interested in doing that. And if you want to do that, you can get certainly by entering github.com/happycakefriends.
We're not malicious, we're really kind. Happy cake friends, right?
I mean, we're not dangerous. And then /certainly. And we're really serious because we have stickers. I mean, that means that it has to be real. And to make it even more real, we did 100 of these very limited, certainly Y2025 stickers. And you can get those by getting over here and get one of those 100 if you want to. This is joohoi. I'm at STÖK Fredrik. Thank you for coming to our talk.
Thanks. Good stuff.
We won't be doing any stage questions. Instead, if you want to talk to us, you can find us. We'll be around here and have a good time.
Bar.
Karaoke.